In this video, let's take a look at notes 10.3, more probability. A compound probability is a probability involving two or more events. For example, the probability of event A and event B happening. Example 1. What is the probability of flipping a coin twice and having it come up heads both times? Well, the probability of coming up heads is 1 out of 2. It's either going to be heads or tails. What is the probability the first flip comes up heads and the second flip comes up heads? So let's take a look at all the options. If I were to flip the coin, I could have 2 heads, or I could have heads and tails, or tails and heads, or tails and tails. So if I flip twice, there are 4 possible outcomes. If I want the probability of the first flip heads and the probability of the second flip heads, that is 1/2 times 1/2, which is 1/4. If you look on this chart over here, how many happen with both heads? This is just 1 out of 4. And so we're getting the same answer whether we look at our list of outcomes or we use this compound probability where we multiply. So the multiplication rule, when calculating the probability of 2 events, event A and B, if the events are independent, then the probability of both events happening is probability of A times probability of B. In our coin flipping, these were independent events. Because I flip and get a heads the first time has no effect on flipping the second time and getting a heads. So independent events, it says 2 events are independent if knowing that one will occur or has occurred does not change the probability that the other occurs. So let's take a look at 2 examples. A randomly selected student is female. What is the probability she plays soccer for SCHS, for Samuel Clemens? Are these independent? Yes. So these are independent because, well, we have girls soccer. Now, in this second example, it says a randomly selected student is female. What is the probability she plays football for Samuel Clemens? Well, these are not independent because we don't have any girls on the football team. So do you see the difference here? You can pick a girl and she can play soccer. That's fine. But if you pick a girl, what are the chances she plays football? That's not going to happen. So these 2 events are not independent. So let's take a look at compound probability and replacement. A bag contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. We've seen this before. We've got 13 marbles, right? If 2 marbles are drawn at random from the bag, what is the probability? First drawing a green and then drawing a yellow. So this is the probability of a green and the probability of a yellow. With replacement, that means we take the marble out of the bag and we put it back. Therefore, these events are independent. Just because we picked a green the first time is not going to affect the probability of the yellow. So this is going to be 6 out of 13 and 3 out of 13. And when we multiply this is 18 out of 169, and as a decimal, approximately 0.107. Now, without replacement, so if we pick the green one the first time, so probability of green and probability of a yellow given a green was picked. So this line right here means given. So the probability of green, well, that's still just 6 out of 13. But if I take a green out, now I have 12. So I have one less. Now, it doesn't affect the number of yellow, though. We still have 3 yellow. But you can see that this is going to change our numbers because, well, 13 times 12, oops, you know what I'm going to do? I'm going to reduce these numbers first because I can't do this math in my head. Look, make that a 2. And so that's going to give me 3 out of 26. And as a decimal, that is 0.115. And so we can see that these are very different numbers. Okay, next example. Drawing 2 blue marbles. So we want a probability of a blue and probability of a blue. And this is with replacement. So we're going to put the blue back. And we have 4 blue. 4 out of the 13 and 4 out of the 13, and that is 16 over 169, which is approximately 0.095. Without replacement, that means we're going to have 1 less and 1 less blue. So probability of a blue and probability of a blue given a blue, a glue, that's crazy. A blue was removed. Okay, so the first one, 4 out of 13. And if we have already taken a blue, then we have 3. Okay, so see our number has changed, and we've also reduced the amount. Okay, I'm going to go ahead and, let's see, I'm going to go ahead and cancel. Let's see, 4 goes into 12 3 times. Hey, and the 3's cancel, so that's just 1/13. And as a decimal, 0.077. Okay, let's take a look at some geometric probability. A probability that is found by calculating a ratio of lengths or areas of geometric figures. Example 3, what is the probability that the point chosen at random in the rectangle will also be in the square? So we want the point, what is the probability of a point is in the square? And this is out of the total. Okay, so if I'm trying to find the area of the total, that is 8 times 6. So the area of the big rectangle, 8 times 6, which is 48. And then the area of the square, well, that's 3 times 3. So this would be 9 out of 48, which is approximately 0.1875. Part B, what is the probability that a point chosen in the rectangle will be in the shaded? Okay, so to find the area of just the shaded, we need to take the total area and subtract the square. And so the total was 48. If we subtract 9, the area of the shaded is 39. So probability of the shaded over the total is equal to 39 over 48, which is about 0.8125. Last example with some circles. The radius of the inner circle is 6, so let's go ahead and draw that on. The inner circle, that's this guy, is 6. The radius of the outer circle is 16. So this big guy is 16. Find the probability of a point selected at random in the outer circle will be in the inner circle. Okay, so the area, let's go ahead and find these areas. So the area of the inner circle, which is just pi times r squared, which is pi times 6 squared, or 36 pi. And the area of the outer circle, I'll call it the larger circle, pi times r squared, which is 256 pi. Okay, so probability of the inner, given the total area, is 36 pi over 256 pi. The pi's will cancel, and 36 over 256 is approximately 0.141. Now the shaded, to find the shaded, we have to subtract the larger minus the inner, and let's see, that gives us 256 pi minus 36 pi, which is 220 pi. Don't drop the pi. All right, so probability of shaded over the total is equal to 220 pi divided by 256 pi. Pi's cancel, and if you put that in a calculator, that's 0.859.